Open the door. Open the door.
I have to replace the door sensor in my Ring home security system. Since I work for a magnetic sensor company, I wanted to see if I could improve it. This is the original sensor from the 1970s. It has a biasing magnet, and its contacts close when it's near a steel plate. There's no magnet in the door, just this plate nailed to the top of the door. But you still need a big hole in the door frame. The spring and contacts wear out, and it doesn't have much air gap tolerance. Here's a newer sensor with a reed switch. You can still get these. This one's from Amazon. The switch assembly goes in the door frame, and the magnet goes in the door. It allows a wider air gap, but reed switches can wear out, and I really don't want to drill a 3/4 inch hole in an outside door because it's conspicuous, it weakens the door, and there's no room for all this in some windows and doors. Nowadays, of course, you can get wireless sensors like this Ring Z-Wave sensor, but they're ugly, need batteries, and have limited wireless range. So I'm sticking with a wired sensor. To avoid big holes, I wanted to use some of these thin neodymium magnets that I can just stick to the door like the old steel plates. And I wanted to put the sensor on the other side of the door frame to avoid a hole in the frame. That requires nearly an inch between the magnet and the sensor, and the reed switches aren't sensitive enough. So we need a more sensitive sensor. This is a 1 millitesla GMR switch. It has no moving parts, of course, and it's much more sensitive than a reed switch, and can operate with the magnet more than twice as far away.
Won't you open up that ever-loving door? Open the door. Open the door.
NVE has a web-based model to predict the fields from various magnets at any distance.
Open the door.
We specify neodymium for the material and enter the approximate magnet dimensions.
Open the door.
We'll just look at the field versus distance. Since the AD025 GMR switch has a 1 millitesla operate point, we move the virtual magnet to get a 10 Oersted 1 millitesla field. The model predicts 33 millimeters, which is about what we found experimentally. So the GMR switch can work through the door frame thickness and the gap between the door and the frame. There are no holes in doors and no moving parts, so the sensor will outlast the house. The sensor is powered by the 5-volt USB that powers the keypads, but the sensors will also work on 12 or 24 volts. The sensor output is connected to a ring bridge for wired sensors. And when the door opens, the alarm sounds. Here's what we used for this project. All of the parts are easy to come by. GMR switches are simple 3-terminal devices. They come in a range of operate points. We're using the most sensitive one. Features that make these sensors ideal for intrusion detection include high sensitivity for wide air gaps, solid-state reliability, wide supply range, and excellent temperature stability. Click email or call NVE for more information or to buy sensors or evaluation kits.